Hi everybody, welcome to Spell Check 4.1 exercises. So for number one, we are being asked to find the amount of money accumulated in 10 years if $14,000 is invested at 6% interest and compounded annually, quarterly, monthly, and daily. Okay, so here is we're calculating our compound interest. So recall that the formula for this is the amount equals the principal times 1 plus the rate over your compound raised to the compound times time. So here's where we will pick through our values. So accumulated in 10 years, that would be our time. So T equals 10. If you invest $14,000, that's the principal that you are starting out with. So P equals 14,000. This 6% is our interest rate. So R would equal 6%, but we need it as a decimal. So this would be 0.06. And we are compounding this in different situations. So annually would be once a year. So this would be N equals 1. So let's go ahead and calculate this. So plugging everything in to our formula would be 14,000 times 1 plus 0.06 over n, which is 1, raised to the 1 times 10. And so if I put this into Desmos, I would get 14,000 times 1 plus 0.06 divided by 1 raised to the 1 times 10. And what I get is 250,000, excuse me, I put an extra zero on this 14,000. I get 25,071.87 cents. Let's go ahead and write that in. So I end up with $25,071.87. Okay, great. Let's move on to the next compound, which is quarterly. So quarterly is 4 times a year. There's 12 months in a year. So you're splitting up into quarters, which would be 4. So same thing. I'm going to have my amount equal 14,000 times 1 plus 0.06 over 4 times 4 times 10. Okay, so going back to Desmos, the great thing about Desmos is that you can go back in and just interchange some values. So I'm going to delete the 1 and change that to the 4 since we're compounding quarterly. And this is the value I get, 25,396.26. Okay, so this would equal 25,936.26 dollars. Okay, so now monthly, well, that's just 12 months in a year. So this would just be compounded 12 times a year. So we're just copying and pasting the same thing. So let me go ahead and do that. Just change a couple things. So we're compounding quarterly, or sorry, monthly. So I end up deleting these 4s and inputting in 12s. And if you go back to Desmos, delete the 4s and put in 12, and we get 25,471.55. All right. So 25,471.55. And likewise, daily, that just means every single day you're compounding, and assuming that we're not in a leap year would just be 365 you are compounding. So copy and paste, delete a couple things. So not 4, this time it would be 365. Okay, so going back to Desmos, what I do is change these 12s to 365. Oops. Okay, and I end up with 25,508.41. Well, 508. 25,508.41. So you see, the more we compound, the more money we make. Okay, so that's compound interest questions. So the next question for 4.1 is a logistical growth model. So here the model of number of automobile sales in developing country is N of T equals 159,000 over 1 plus 5.2 e to the negative 0.3 times T minus 2010, where T is greater than 2010. So that's our starting year. And N is just a number of automobiles sold in 1 year. So how many years or how many cars were sold in 2025? So in 2025, we don't really have to change any years because we're talking about the given year. So this would just be T equals 2025. So all we need to do is plug in 2025 into this logistical growth model to see how many cars we'd sell in that year. So we would have N 2025 equals 159,000 over 1 plus 5.2 e to the negative 0.3 times 2025 minus 2010. So let's go ahead and simplify this a little bit before we put it into Desmos. So this would be, I'm going to write the denominator first. 1 plus 5.2 e to the negative 0.3 times 15. And this is all over or all under 159,000. Okay, so now feel a little better about putting this into Desmos. So let's go ahead and do that. So Desmos, and I'm going to plug in this equation. So 159 000 divided by 1 plus 5.2 e to the negative 0.3 times 15. And I end up with 150,316.69. So let's go ahead and write that down. Well, 316.69. 316.69. But then we want to round up to a whole automobile and not have a decimal. We can have decimals of cars. So this would be 150,317 cars or automobiles, but same thing. Okay, so that's how we could predict in the year 2025 how many a developing country cars they would sell. Now, with part B, what is the maximum number of cars to be sold? So recall what a logistical growth model is. So logistical growth model, the standard version of it is m over 1 plus a e to negative kt, where m is the maximum level of output. This is our maximum level of output. So that means for this logistical growth model, this 159,000 on the top is our M. Use a different color, is our M. So the maximum level of output that we can have of cars sold is 159,000. So that's all we have to do is check out that 159,000. So 159,000 cars is the maximum number of cars sold. Okay, so that's for 4.1. Let's move on to 4.2 and work on some of these exercises. So 4.2, we want to convert exponential equation to a log equation. So recall that t equals a natural log of a if and only if a equals e to the t. Okay, so we want to convert y equals e to 3x plus 5 to a natural log function. So what this would end up being is natural log of y equals 3x plus 5. So I'm going backwards. And likewise, we want to convert a log equation to an exponential equation. So now I'm going forwards. And what this would end up being is e to the x minus 1 equals y minus 2. Okay, so part 5 is solve the exponential equation. I need to figure out what x equals. So I need to get x out of this exponent and get it on the floor level. So what I need to do first is divide both sides by 151, and that cancels out. E to the 5x minus 6, and I'm going to leave the 102 over 151 alone because I'm not going to get an exact decimal. Because what I need to do now is take the log or natural log of both sides to get that exponent, to get that x value out of the exponent. So what this is going to do is cancel out that natural log and that e. And so let me bring the work up here. But what I'm left with is 5x minus 6 because this brings down that x that I'm looking for equals natural log of 102 over 151. I recommend not calculating this out all together now and wait till the end so that the calculations will be a lot more exact and easier. So now my mission is just to get x by itself. So I need to move some things over to the right side. So I'm going to add 6 to both sides. I'll get 5x equals natural log of 102 over 151 plus 6. And then I'm going to divide both sides by 5. So what I'll end up with is x equals natural log of 102 over 151 plus 6 divided by 5. And for my final answer, what that would approximately be, if I go to Desmos and type in natural log of 102 divided by 151 plus 6, and then the whole thing divided by 5. What I end up with is 1.1215. You see how Desmos just makes life a lot easier for us. So what I end up with is 1.1215. And that is my answer. Okay, so that's it for this video. I'll see you next time. Thank you. Bye.